So today's lesson is primarily focused on geometric sequences, or basically just patterns of numbers in general. We have looked at patterns of numbers before when we did arithmetic sequences. So we're going to kind of touch on that as well today, because you will see a little bit of both on your test this Friday. So number one, on the back side of your practice, you have like a bunch of free space. Even if you didn't get to it, just kind of fill this in on the back side as we go through them. But what is the pattern between these numbers? What is happening each time? So like between 2 and 9, and then 9 and 16, what's the trend? We are adding 7. And is it consistent throughout? So then what number fits in here? 23 is correct. All right, so when you are adding the same number each time or subtracting the same number, those are our arithmetic sequences. So just kind of write that to the side there. All right, when you add or subtract something each time, those are arithmetic sequences. And it has to be consistent throughout. If it's not adding 7 at least once through these, then it's not. And so arithmetic sequences have what's called a common difference. We talked about this before. It is always whatever number you are adding to get to the next number. So the common difference of this first set of numbers is 7. All right. If instead I was subtracting 7 each time, then my common difference would be -7. All right. So just whatever number you need to add to get to the next number. Now, between the numbers in number 2, what's happening? Are we adding 3 each time? No, because 6 plus 3 is not 12. What are they doing each time? Multiplying by 2 each time. So what number fits in here? 24, good. 24 times 2 is 48. 48 times 2 is 96. All right, so when you are multiplying each time to get to the next number, those will be our geometric sequences. So just kind of write that in. All right, so when you have to multiply each time to get to the next number, those are geometric sequences. Instead of a common difference, we call it common ratio. We're not adding each time, we're multiplying each time. So since we're multiplying 2 each time, our common ratio is 2. Makes sense? Any questions? All right, what's the pattern in number 3? So what can I do to 1 to get -3? And then see if it's consistent throughout. All right, if you're thinking like subtracting 4, well, you know that doesn't work because between these two numbers, you do not get that. So what are we doing? Multiplying by -3. And how do you know it's negative? Because the signs are alternating. All right, we go positive, negative, positive, negative. So we are multiplying the -3. So what number fits in this last space? What's -27 times -3? Is positive 81. Good. All right. So an arithmetic sequence or a geometric sequence? Geometric, because we're having to multiply each time. All right, so it's a geometric sequence. What's our common ratio? -3. So whatever you multiply by to get to the next number. All right, number 4. What's the pattern here? How can I go from 100 to 20? 80, but then it looks weird. I get a fraction at the end. So what else could I do? All right, any clue? So maybe try seeing what 100 divided by 20 is and just see if that makes a pattern. All right, what's 100 divided by 20? 5. So if I divide 5 each time, see if that works. What's 20 divided by 5? 4. And then 4 divided by 5 is 4/5. So that makes sense. So we talked about like multiplying each time as a geometric sequence. So this is a geometric sequence, even though we are dividing each time by 5. But here's how we write the common ratio. So yeah, we're dividing 5 each time, but the common ratio needs to be written as what you're multiplying by each time, which would be 1/5. All right, we'll talk about that in a second, why it's like that. But if I do 100 times 1/5, I get 20. 20 times 1/5, I get 4. 4 times 1/5 is 4/5. All right, last one, what's the pattern? Subtracting 5. So then let's see, what would 88 minus 5 be? 83. And then see if the pattern keeps going. Subtracting 5 does give me 78. Subtracting 5 does give me 73. What's 73 minus 5? 68. All right, so since it's consistently subtracting 5 each time, what kind of sequence is that? Arithmetic. All right, so arithmetic sequences, and this time our common difference is -5. All right, so when I say like I'm adding -5 or I'm subtracting by 5, those mean the same thing. All right, so questions. All right, a sequence of numbers in which the ratio known as R remains constant. All right, so a sequence of numbers in which the ratio, which is R, remains constant. So if it's different between just one set of numbers in that sequence, then it's not a geometric sequence. It has to be the same throughout. All right, common ratio, which is your R value, is going to be found by dividing each term by its previous term. All right, a sequence of numbers in which the ratio remains constant for geometric sequences, and your common ratio is found by dividing each term by its previous term. All right, so identifying a geometric sequence, we kind of did that in the Beller. Now in these 6 problems, they may or may not be. All right, so we're just trying to make sure that the ratio remains constant throughout. So for number 1, let's try finding what the common ratio could be and then just see if it's constant throughout. So how do you find the common ratio? So it says dividing each term by its previous term. So maybe take like one of the terms, like 10, and divide it by its previous term, which is 2. What do we get? We get 5. So just see if it's constant throughout. So 2 times 5 is 10. Is 10 times 5 50? Yes, no? Yes. Is 50 times 5 250? All right, yes. So then, yes, it is a geometric sequence because it's constant throughout. It's constantly multiplying 5 each time. Questions about that? All right, so then number 2. Again, try and identify your common ratio. So take one of the terms, like 45, and divide it by its previous term, so 135. If you put that in your calculator, I think you get 0.3 repeating, which, if you didn't know, is the fraction 1/3. All right, fractions are usually better to use because they're more exact than decimals, which sometimes you have to round. So multiplying 1/3 each time. How else could you like phrase that? All right, saying that I'm multiplying 1/3 is the same thing as saying dividing by 3. All right, but either way, if this is a geometric sequence, then the ratio should be 1/3. All right, so just see if it's correct throughout. So is 45 times 1/3 15? Try it out in your calculator. You don't have to wait for your classmates to do it for you. All right, yes, and then it's 15 times 1/3 5. Yes, so it is a geometric sequence. All right, try 3 through 6 on your own, and then we'll review the answers in about a minute. So figure out if it's a geometric sequence, then identify the common ratio. Yes or no? All right, so what you probably did was do maybe like 18 divided by 6, so one term by its previous term and got 3. But when you keep going, it's 18 times 3, 24. All right, no. So then that tells you it is not a geometric sequence if it doesn't have a constant ratio. So then number 4, is it a geometric sequence? All right, yes it is. What is the common ratio? Positive or negative? Negative. And how do you know it's negative? When the signs alternate. So back and forth, positive, negative, you know that you multiplied a negative number. Earlier someone said because there is negative numbers, but like if you look at number 6, so we're gonna skip 5 for a second. Is number 6 a geometric sequence? Yes, no. Yes, what's my ratio? A +4 this time. Because yeah, there's negative numbers in the sequence, but do the signs ever change? All right, no, so that means you multiply a positive if the signs do not change. All right, is number 5 a geometric sequence? Yes, and the common ratio is Medina. No, he is not. No problem. All right, what is the common ratio? Negative 1/2 is correct. -0.5 is fine because it's a decimal that ends, so that works too. But fractions are usually better to use. All right, and that's what you'd be multiplying each time. Kids love to fight me on this. They like to say, but it's dividing -2 each time. The common ratio is -2. All right, it's just not. All right, the definition is what you get from dividing each term by its previous term. So questions, comments? All right, for continuing the geometric sequence, I have faith in you guys. We just did it in the bell work, so we'll just do maybe like 1 or 2. So look at number 8. In order to continue the sequence, what do we need to identify? The common ratio. So take one of your terms, like maybe 768. Do I divide it by the term that's before it or after it? Before it. All right, divide each term by its previous term. So when I do that, what do I get? 1/4 or 0.25 is correct. I don't know why I put I don't know why I put that. 1/4. All right, or in other words, dividing by 4, but the ratio is 1/4. So do that each time. What's 192 times 1/4? 48, good. What's 48 times 1/4? 12, and then 12 times 1/4. 3. All right, you see how the numbers started out really big and then got really small? All right, those are our exponential functions. That's why it's in this unit. All right, so good. Number 10 we'll look at. What's the common ratio in number 10? So take one of the terms like -25 divided by its previous term, -5. What do I get? A +5. So to find the next term, I need to be multiplying each number by 5. So -125 times 5 is -625, good. That number times 5 is -3,125. And then that number is times 5 is good. All right. Questions about this half? Everyone wake up now, because now we're actually getting to something that's more challenging. And I will not be here to help you on it tomorrow. So questions. Everyone sit up now then and pay attention. So take a right word. Sit up. We need you alive to understand this. This is actually where it gets difficult. I don't think it's that difficult, but we'll just keep going. All right, so we did this last semester too. Arithmetic sequences have like explicit and recursive formulas. Well, so do geometric sequences. They also have a recursive formula, but we're not going to focus on that this year. You'll see it in geometry and algebra 3-4. So this year we'll just look at the explicit formula. So just kind of write that in here, that the geometric sequence formula is also known as the explicit rule. All right, and I will provide you that formula. It's right here. It'll stay here throughout your test. So copy this rule over here. The rule is a sub n equals a sub 1 times r to the n minus 1. All right, I'll provide you the formula, but I won't tell you how to use it on your test. You have to know how to use it on your test. All right, I'll tell you how to use it now though. So n stands for nth term. So n equals nth term. And so n can be replaced with any number. So like if you were told to find the 100th term, would you really want to like continue the pattern 100 times till you get to the 100th term? Right? No, that would be a bad use of your time on the test. So what you can do is use this formula, replace n with whatever number it tells you to find. So if it told you to find the 10th term, n will be 10. If it told you to find the 90th term, n will be 90. So it just stands for nth term. A sub 1, you guys remember what that stands for? So if A sub 100 is my 100th term, then A sub 1 is my first term. All right, so write that in there. You need to be able to identify the first term of every sequence. And then R is going to stand for what? It's what it was earlier when we did all these. Your common ratio. All right, so if you can identify your common ratio, which we just did a bunch of times today together, and if you can identify your first term, then you can use this formula to find any term in the sequence. All right, so we'll do a couple examples, you'll try some, and then you guys might even have time to start your practice. All right, so the rule I'll copy over so you guys have it as a reference. But what two things do you need to be able to identify? First term, so what's my first term in number 11? 3. And then I also need to be able to identify my common ratio. So just take any one of your terms, except maybe the first one, so like 9, divided by its previous term, 3. And so what's my common ratio? 3. All right, just plug that in. So replace A sub 1 with 3 because that's what we found. Replace R with 3 because that's what we found. And now we have a rule that we can use to find any term we want. Let's see. All right, and I didn't read the instructions. The instructions said to make a rule for the nth term. That's what we just did. So writing it with the n's in it would be the rule for the nth term. Any questions? All right, and then it says find A sub 7. So what is A sub 7? What does it stand for? The 7th term, good. So it replaces what in the formula, the 7? It replaces the n, so it's normally A sub n. So anywhere that there's an n, replace it with the 7 into that rule we just made. And while we can simplify this by hand, it's probably just be easier to put what's to the right of the equal sign in your calculator. Just make sure if you do that, either do 7 minus 1 in your head and put that in, or put your exponent in parentheses. Otherwise, Desmos or your handheld calculator won't read it right. So I'll show you with Desmos. I have 3 times 3 to the 7 minus 1. Again, in parentheses, because if I do it without it, it like kicks it out. Right, like it won't let me do it. All right, and then we get this number, which is our answer. Other way you could do it is just do the 7 minus 1 in your head, type that in, and we get the same answer. So it's up to you. So my seventh term is 2,187. All right, questions, comments? All right, we'll actually do one together on the back side so that you can see what it looks like with decay, not just growth. All right, so let's look at 13. So number 13, here's that rule again, which you will be provided on your tests. We just need to identify what two things to be able to use it. I need to identify a sub 1, which will be what? 400, the first term in the sequence. And I need to identify R, which you find from taking one of your terms, like 200, and dividing it by your previous term, like 400. What do we get when we divide that out? $200 by 400 is 1/2 or 0.5. Both of those are acceptable because the decimal does end. All right, but I'll show you as a fraction. So plug it in the right spots. We said a sub 1 is 400 times your common ratio, which is 1/2 to the n minus 1. So make sure your ratio is the one that has the n minus 1 attached to it. I'm going to box that up because that's part of my answer. It just wants the rule for some of the problems on your test. Or it might give you the rule and say, what's the first term? What's the common ratio? And then we need to find a sub 7 for the instructions. So plug in 7. You have a sub 7 equals 400 times 1/2 to the 7 minus 1. And don't struggle with it too much. Just go ahead and put it in your calculator. Practice with whatever calculator you want to use for the test. All right, fractions should be in parentheses so that the calculator reads it right. And if you're typing the whole thing in, then your exponent should be in parentheses too. All right, otherwise do the 7 minus 1 in your head and enter it like that. Either way, you still get 6.25 as your 7th term. Questions about that? All right, so then for the your turn, you guys will do number 14 and number 16. So try those. I'll give you about 2 minutes. So the key things that you need to be able to identify is the first term in the sequence so that you can put it in the a sub 1 position. So if you need the formula, look at the board. It's going to be on the board throughout the test. So a sub 1 is 1. My common ratio is 5. So take each term divided by its previous term. That gives you what R is. All right, make sure R is the one attached to the n minus 1. And then to find the 7th term, it won't always ask you for the 7th term, but it does for these problems. You just plug in 7 where the n goes. So questions about that? All right, and then don't make your life hard. Use your calculator. Practice using it. When you put in your calculator, you get 15,625. Now for 16, same thing, except we're looking at decay and we're looking at negative numbers too. So first term in the sequence, 729. To find R, which is not that clear here what it's doing, Take each term, divide it by its previous term. Get -1/3. All right, put it in the correct spots. Put it in your calculator. If you're getting anything other than 1, then let me know. All right. Make sure you follow the instructions from the sub on the board. You have your practice to work on tomorrow. You have your exit ticket to work on tomorrow. And I'm even going to leave you a little study guide. So lots of things to do tomorrow while I'm not here.